Awesome. So, Stephanie, welcome to the stage. Stephanie, how are you today?
Thanks. Good. How are you?
Good, thank you. Thank you. So, in introducing Stephanie, Stephanie began her interest in additive manufacturing working as an intern at UCI's 3D printing lab while completing her bachelor in mechanical and aerospace engineering. She went to work on as an application engineer in the field and then at a 3D printing service bureau. Through both jobs, she was exposed to many different additive manufacturing technologies and machines. In January 2021, Stephanie transitioned to the automotive industry and started at Rivian. As the design studio's first additive lead manufacturing engineer, she has worked to optimize operation of the 3D print lab. Her experience with many different additive technologies is key to her ability to present new solutions and use additive manufacturing to improve the traditional design process. So I'd love to hand over to Stephanie now, and she'll take you through her journey.
Awesome. Let me bring up my presentation. Screen two. All right. We can get started. So thank you for the introduction. I am Stephanie. I am the lead additive manufacturing engineer here at Rivian. And today I'm going to talk to you about how we utilize additive manufacturing in the automotive design studio. As I go through the presentation, if you have any questions, feel free to drop them in the lovely Q&A feature and we'll get to them at the end. So first of all, what do we do in the design studio? So the design studio is in charge of how the vehicle looks inside and out. And we're going to talk about both facets and how we use 3D printing in both areas. But let's start with the exterior of the vehicle. So this is always going to start with 2D sketches. And we'll have our designers do dozens of different 2D sketches when we're beginning to design a vehicle. And from there, we'll choose 3 or 4 to become scale models, and we'll mill those designs out of clay and then refine them with the designer working with a clay modeler in order to decide which themes we're going to select to become a full-size scale model or full-size buck. We'll usually choose 1 or 2 themes to become a full-size model. And so a buck is constructed using a steel and plywood frame, and we glue foam onto that, which is milled to our data set, and then to an undercut of our data set, and then we apply the special automotive clay, and that's milled to surface data, whatever we're starting with. The clay modelers will come in and they'll clean up all the mill marks or even refine the design further if that's needed too. And then we'll apply a Scotch Cal or a Dynoc wrap, which is basically just like a vinyl wrap that makes the clay look like it's painted. And then once we install our 3D printed hard parts, it really is amazing how real these vehicles look from across the room. You would think that you could open the door and get in and drive it away. It's pretty amazing. So specifically, when we're designing our vehicles, some of the parts that we'll print for the full size and the scale models I have indicated here. So this is actually a picture of a production R1T, which is Rivian's truck. And the parts are usually kind of divided into 2 categories. So the first being parts that are just printed kind of solid as one piece. And these parts will get a singular finish. So for example, the tow hooks and the grille, they'll both be finished to look like production parts. And then the door handles, those would actually be wrapped in the same wrap that the body side is wrapped in so that it looks like the same and it's matching. We also have the parts that are indicated in blue, for example, the wheels, which depending on how many finishes you have, we might have 5 to 10 parts per wheel times 4 wheels. So you can see how the amount of 3D printed parts that go into these models really adds up over time. In addition to that, we'll print the side mirror. That will be 3 different parts. the bottom lower, which would be printed and finished with a high gloss black paint to look like production materials. Then we'll do a 3D printed clear lens, which will be polished up, and the upper, which also gets wrapped in the same material as the body side. To kind of give it that extra touch of realism, we'll actually take mirror stock and laser cut that to the correct contour and glue that to the opposite side of the mirror. So like it actually is a mirror. From across the room, you wouldn't be able to tell that it's not a real vehicle. Well, from right next to this mirror, you probably wouldn't be able to tell that it's not an actual production mirror. For the headlamps and the tail lamps, we do those as well. That's kind of my favorite bit of it. I think that's what gives the models that extra sense of realism. I'm going to go into a lot more detail on those later, but right now let's focus in on the Rivian headlight, which is kind of Rivian's design signature. So that is present on the Rivian truck and the SUV. So this one pill, which is actually comprised of 8 different 3D printed components. So we have the 4 projectors shown by the red arrows, which are polished clear lenses. And then we have this carrier, which is shown by the yellow arrow, which is going to be printed and painted in a high gloss black paint. And then the light ring, which is shown by the blue arrow, which goes all the way around the headlamp. This whole assembly will be held together with another 3D printed part from the back, and then a clear lens that goes over the entire thing. So again, this one small piece is actually 8 different 3D printed components. So it's something that we utilize a lot. In addition to that, we'll also print badging with the logo or the name, sort of give the extra sense of realism on the models. Sometimes we can get the production parts because the parts are in production and we have them at the factory, but it's not always something we can get our hands on in the studio. So it's really nice to have the option to just pull the production data and print the parts out and have them, ready to install in the vehicle the next day. It kind of gives us an advantage, and a lot of time it kind of saves the day because of the quick turnarounds. Just like we design the exterior of the vehicle using bucks, we also design the interior of the vehicle using bucks. And this is what sort of looked like something like this. So this is a property that's designed to allow us to evaluate the interior of the vehicle. So it's a full instrument panel, a driver's side seat, a passenger side seat, steering wheel, center console, and also the interior of the doors are also designed in there as well. So when you're sitting in there, minus the windows, it feels like you're sitting in an actual vehicle. So for these type of interior bucks, we can produce them in different fidelity levels depending on what we need to evaluate. Kind of the highest level or the last step of the process would be a CMF buck or a color, material, and finishes buck. So this would be something that we would design to look like the final product. So these are some pictures here. They're actually of the production data, but you can kind of get an idea of what we'd be evaluating. So if you look at the picture on the right, that's the interior of the door. And for something like this would be constructed with a combination of 3D printed parts and milled parts. So the main door would be milled foam, and then we would 3D print that the lower section of the armrest in the gray, which would be sent out to be wrapped in a vegan leather. And then the bezel and the door handle would be printed and then finished with that silver finish. And then we'll do the armrest upper, which is also wrapped in a different vegan leather, and then the wooded bezel. So when we're doing something like this, it really looks like the production data, and it, the way that what it does is it allows us to be confident that we're on a correct design decision sooner in the process rather than later. And in the design studio, time is like always your most valuable commodity. So as sooner you can put yourself on a design path that you feel confident in is really a huge, huge advantage. And that's kind of where additive comes in, because we can take the data that's still, in process or, hasn't even, been sent out to be designed to be production yet, and we can wrap those in what we're expecting to be our production finishes and make design decisions. So what we'll actually do is produce multiple different sets of these parts, so we can actually have the designers evaluate multiple trim levels on the same property, which is really great because it saves us a lot of space, and all of it is designed to be hot swappable so that it can be changed out very fast and efficiently. The same thing with the center console. So we'll design, we'll print the armrest and the silver bezel and maybe even that rubber mat with the wood trim. And we might print 2 or 3 sets of those and have them be hot swappable so we can evaluate different trim levels. So I like this picture on the left because it's a really great example of how we use additive and subtractive technologies together, which we do a lot. So you can see the main instrument panel is this white foam. This isn't a Rivian vehicle, but the picture illustrates the idea very well. So you can see this white instrument panel of milled foam, and then we have this handle in the front that's actually a different material. So for us, we would actually 3D print this handle. And the reason we do that is because it would be difficult to mill because of the undercuts. And so instead of spending a lot of time trying to mill that part as one piece, we just cut it up in data and print it in parallel to the milling. So we allow our milling team to do what they do best, produce these very large parts out of the foam material, which is very lightweight and easy to manage, and then let the additive do what it does best, which is print something that the geometry, the machine doesn't really care. So it will do what, for the most part, whatever you ask of it. It doesn't care about undercuts like a machine tool would. And then we'll put those parts together at the end of the process. And again, this is just something that allows us to get to the final step where we can evaluate the design sooner. And even just having additive as a tool is great, but having it in-house is really fantastic because we can really, really take advantage of the tight turnaround times that additive allows. So just like an exterior buck, where we're using clay to evaluate the geometry of the vehicle, we'll do the same thing on an interior buck. So we'll create this interior buck that's actually all milled clay, at least from a starting data set. And for this type of model, the reason we produce this is so that our clay modelers and designers can evaluate the geometry in real time and actually change it as design needs change, and we're looking at it, and it's really a great way for them to sort of finalize and get that last bit of perfection on the geometry. And there's always parts that we know are not going to change. So like the screens might not be changing, the vents might not be changing, the cup holders might not be changing. So we'll actually mill in pockets to accept 3D printed hard parts. So when it's time to evaluate that data, we will install them into the clay, and everything can be looked at in sort of to see everything at once, to see it with the screens and the cup holders and the vents. And then when it's time to make the changes, we'll remove those parts, and it's a lot easier for our modelers to make big design changes on the surfaces without those parts being in the way. So it's kind of the best of both worlds, and it's just a process improvement that lets us better evaluate and work on these types of bugs. Something we do a lot is models that are just going to be shown on a tabletop. So they don't necessarily have a buck to go into, but it's something that we want to look at anyways. And this can be, steering wheels or cup holders, or even portions of the IP geometry that we might be looking at, or grab handles, anything you kind of want to see or feel before you want to set yourself down on a design path. We'll use additive to bring that to life before we kind of make a final decision. So if we're looking at a steering wheel, I can print, 3 or 4 sections of different designs of a steering wheel overnight. And within like 24 hours, the designers have those parts in their hands and they can hold them and feel confident on a design path within one day, which is pretty amazing. And it's something that we do a lot, just kind of as a gut check, but also to make sure that with every step of the process, we feel like we're still going on the correct path. And so we don't have to pivot later, because, you know, that's something we're willing to do, but if we don't need to do that, that's always better. Something I don't print parts for that often, but I think it's kind of a cool application, is parts for VR bucks. So just like we evaluate the interior and exterior of the vehicle in clay and real space, we'll do the same thing using VR environments or AR environments. So when we're evaluating the interior of the vehicle, we'll actually design a buck that's just like a driver's seat and a steering wheel and maybe some pedals, so that when you sit in the seat and you put on the VR goggles, you can reach out and you can touch a steering wheel and you can put your feet on the pedals. And it kind of just gives us an extra bit of realism for the VR environment. So every once in a while, I'll get a request to print a steering wheel or a pedal or something like that. Not too often. Usually those parts, you know, they last a pretty long time and there's not a lot of changes, but it's just something coming from a space where I'm way more familiar with additive than I am the automotive environment. It sort of was like, oh, I didn't even think about that as an application for additive, but it's a pretty cool one. You know, it's a lot of different technologies coming together, which I kind of like. To go into kind of a more specific example of how we use additive in the studio, here's an example of a project we prototyped and created using 3D printing, is our CMF capsules. So this is something we designed in-house to be sort of a first step to evaluate our different trim levels on the vehicles. So these parts are made with a bunch of different finishes and assembled from 3D printed parts. So there's the pink in the CAD. You can see the pink centerpiece and the base are both with like a metallized finish. And then we have the yellow centerpiece, which is a fabric wrapped 3D printed part. And then the teal base, which is designed to accept a wooded section of the instrument panel. And then this green half circle piece, one of them is fabric wrapped and the other is wrapped in a vegan leather, the same as the main body, which is shown in purple, which is wrapped in vegan leather with a decorative stitch. And this is something we prototyped in-house. And because of all the different finishes of these parts coming together, there was a lot of tweaking and sort of adjusting the CAD and reprinting and getting them wrapped and finished, so that when we finished assembling them, they went together very easily and very cleanly, but also the fit and finish of this sort of example piece to show our trim levels matched the high level of finish that you'll see in the vehicles. So not only do we have something that to look at in the studio that kind of is more representative of the final product, but we also are able to use these to display to our customers our current trim levels. So here's a picture of these capsules on display at our Rivian space in Venice. So this is a community space for, you know, gatherings and workshops for the community, but it also is a space for Rivian to show the community, you know, what we do as a company, what we're about, and to see our products. So if you go there, you'll see these and you'll know that they're 3D printed. So you might even have a little bit more information than the people that work there. Who knows? To go into more detail on the full-size lamps, this is some specific example and print times of what we do to produce a full set of lamps for a full-size vehicle. So you can get an understanding of how we actually utilize the technology and how it helps us. So like I said, the lamps are kind of my favorite part of it. I feel like that's what really gives the clay models like a lot of life. And so this is something we print quite often. And you can see these parts are not small. So we have the light bar that goes across the whole front and the whole rear of the vehicle. And for this design, which is shown here, which is, I think these are pictures from the car show. These parts weren't printed, but you can see the design at least. The design is actually 34 different printed parts. So again, it kind of adds up fast when you have different components that all go together and different finishes as well. So, for me, when I get this set of data, I'm kind of thinking about how are the parts being finished and what materials do they need to be made out of. So it's split into 2 builds here. I have 2 PolyJet machines. The first build is for all the clear parts, and these would be parts that would be printed in clear and then polished to look like the production design. And it's about a 2-day build. So if I get data on Friday, by Monday, the parts are coming out of the machine ready to be cleaned. And then Monday to Tuesday, I can do a photo bleaching operation, which makes the clear parts more clear. And by Tuesday, those parts are ready to be polished and to be finished for the actual model. The second build is for the painted parts. So there's more of those because there's more parts that need to be painted. The build's a little bit longer. It's about 5 days. So from Friday to Wednesday, the print will be running. And by Wednesday, the parts will be ready to be taken off the machine and be cleaned up. So from getting brand new data on Friday to Wednesday of the next week, I can have a full set of headlamps and tail lamps ready to be finished and installed in the model. It's just like such a huge advantage for us in the studio. That short timeline is pretty incredible considering the different finishes, the different material requirements, and also just the size of the parts and the quantity, because they're definitely not small parts. And allowing our designers to be able to actually look at their designs, not only on a table, but in the clay where it's actually the production intent geometry around these parts. It's a huge, huge advantage. And it's something we definitely take advantage of, having additive as technology we can use, and also like in the studio at the facility we're doing the design work. And it's really a huge advantage for us. The last little application is for a steering wheel mock-up. So this is something that we'll design when we want to, or produce when we want to modify a steering wheel using clay and have the designers work on it with the clay modeler. And this would be produced traditionally using a steel frame, and which would be packed with clay and then milled to a starting data set. And then the clay modeler and the designer would work on it. What I can actually do with additive is take that starting data set and offset it inwards like 10 mils and print the frame out of an FDM or FFF machine in sparse and have it ready pretty much the next day to be packed with clay and milled. And again, the time savings between something that would take 2 or 3 days to produce traditionally and take 24 hours to produce using additive is a huge savings for us. It's the time savings is what we're always looking to do. It is a little bit more expensive in cost, about $290 in material compared to $40, but we're always looking to save time. It's also lighter weight, which is easier for the designers to work with, and we can modify it easier later because it's a plastic structure and not a steel frame, which is great if you're trying to modify it without, with preserving your carefully crafted clay model on the outside of the vehicle, on the outside of the steering wheel. All right, so that's all I have for you this evening. Hopefully you learned a little bit. I think that we have some pretty cool applications, and now I can jump into questions if there's any in there.
Excellent. Thank you, Steph. That's Stephanie. That's awesome. It's actually really good from a point of view, because to see the application in the prototype process and how you're actually changing and adjusting and the differences that you're making. So Carol McDonald has asked, how do you print the very large parts? What type of printers do you use?
That's a great question. So I have 2 PolyJet machines, which is a type of machine that Stratasys produces. And we actually have their J4100. And if you're familiar with PolyJet machines, it's massive. So the build envelope on that machine is 500 millimeters by 800 millimeters or I'm sorry, it's 1,000 across, 1,000 millimeters across, 800 millimeters to the front, and 500 millimeters in the Z. So that is huge for 3D printing. And it really allows us, like all of those light bar parts, we can print in one part without cutting, which is very critical for the lenses because we definitely don't want to bond them and see a line. Also have an FDM machine, and that build area is 2 feet by 3 feet by 2 feet, which is really great when we need to produce big stuff and we don't want to have to fuss with bonding it together.
Yeah, and on that, and because I'm sure when you're printing bigger stuff and the transition and making from the traditional way of prototyping to the new one, it enables you to change the designs easier, and you end up with a design that's a little bit more fit for purpose. It's like form follows function. So one of the great questions on that is, how do you actually manage the tracking design iterations through the physical output options? And that's a question from Matt Griffin.
Awesome. That's also a really good question, and it's definitely very important. And if you've ever looked at a 3D printed part and wondered, when did I print this and what was this? You know exactly why that's important. And so what we'll do a lot is we'll actually put physical labels on the B side. So I can go into a CAD software or a mesh editing software and add, you know, the file name or the date it was printed or the designer who made the part. You know, any of that information can be physically printed into the part, which is a great way to do it. There was one situation where we had 4 different scale models of the same vehicle, all with dozens of the same similar 3D printed parts. And so that was huge. Just putting the initials of the designer to know which model it went with saved us so much time and frustration in the long run.
And typically, how long does it take for you to go from full-scale prototype using additive manufacturing compared to what it was using full clay?
That's another good question. I don't know if I'm the
piece of string.
they get me thinking. I don't know if I'm the best person to answer that because I wasn't there, right, when they weren't using additive, but I can see this. I can see all the advantages. So our clay modelers are really, really very talented, and they'll take a 2D sketch and just by looking at it, they'll modify and redesign the scales. But something they definitely don't want to do is work on a little tiny projector and a headlamp when they should be working on the full body side. So it just kind of allows everyone to do what they do best, because the machine will print out the headlamp that is, you know, very simple geometry, but very small. And it's probably not really changing because, you know, maybe a little bit, but, you know, whatever you have in the computer is going to do the job for the prototype, where they can spend their time modifying the body sides and these big sweeping panels that you really need the designer and the clay modeler working in tandem to produce.
Yeah, and I guess if you've already got an existing model that has, you know, a standard set of lights, then it's not down to changing the aesthetics of that particular part, right? It's about changing the aesthetics of the rest of the vehicle, which is what your designer and your clay modeler does. Exactly. So to go back to questions again, what other technologies do you use in your design studio?
So we have a lot of different technologies, and we like to use them, you know, best tool for the best job. So in addition to the 3D printers, we have mills that mill foam and mill clay. We also have a laser cutter and a vinyl printer and cutter, as well as, you know, a wood shop and a fab shop. And so there's a lot going on all at once usually, but it all comes together, you know, at the right moment and lets us produce these models that really allow our designers to feel confident in what they're putting out there before we get way down the line.
Yeah. Oh, it's change management with design can be quite expensive. So yeah, cool. Does anyone else have any questions for Stephanie before we close up and go back to the main stage for networking? Okay, it looks like we're quiet. So we do have another section that is coming up shortly. So, but for now, I believe that we will be popping back to the main stage for a little bit of networking before the next lot of tracks start. And thank you so much, Steph.
Yeah, of course.
Really enjoyed hearing from you, really enjoyed hearing from Amy, and really enjoyed hearing from, oh my God, please forgive me. It's lunchtime here in Australia and I haven't had lunch yet. From Liz. Oh my God, Liz. So Amy, Liz, and Stephanie, thank you very much for your time today. And if we will all go to the main stage, that would be fantastic. And the next moderator on board is Karen, and Karen will take you on a journey with her presenters as well. So thank you.
Awesome. Thank you so much.
Bye.
Bye.